So given an array of integers norms and an integer k, return the number of contiguous subarray where the product of all the elements in the subarray is strictly less than k. Okay, I'm going to go through a few examples here. Okay, obviously 10, 5, 2, 6 works 10, 5, 5, 2, 2, 6, 5, 2, 6, okay, so my current situation is that I'm going to, the substring problem, I plan to use, I plan to use a setting window. I also noticed that the number of elements, so the elements in the array is larger than 1, so setting window will work since whenever we add an element, the product will grow larger, and when we divide that element, the product will grow smaller. So setting window will work. So I plan to just use the right pointer to move to the right direction, and whenever I see a new one, I'll record the current product, and then I check whether the current product is valid, and if it is, I have found the if it is, it will just go as it is. If it's not, I will shrink the left pointer. And by doing this, the right pointer and left pointer, I got the longest one that is a valid substring. Since I need to return all the numbers of contiguous substring, I will just get subset of those substrings subarrays to get the number of all the valid subarrays. So that's the general idea. I'm going to start coding. It seems like this is stuck. Okay, it works now. Let's go through. So we have a current product. Start with 1. Okay, I think in this part, I'm going to check whether the current product is relevant should be less than k. Check whether it's larger or equal to k. If it is, that means we need to adjust the boundary. So let me think how to adjust the boundary. So when most of all loops stops, so whenever we say, okay, the current one is too large. We just plan to divide by the left one. But when will it stops? So let's be, I can go through some smaller example here. Will the left pointer finally exit? So you increment the left pointer. Let me think when this. So if we just divide the value by the left pointer and we keep increment the left, will it one day exit the right? Will it exit the right? It is possible. For example, if k is 0, and the product will always be, I mean, if k is 0, the product will always be larger than 0, because area element here is larger than 1. So this will make the for loop non-stopping. And if the k is 1, so the worst case is if k is 1, let me think. If k is 1 in this case, it actually stops, because it's always, if there's only one element in the subarray, it will always be like that. So that means this while loop will not stop. So I will add the guard here. If k is smaller or equal to 0, we'll just smaller or equal to 1. That means okay, so that means what we want to return the number of contiguous subarrays. So if k is equal to 0, obviously there is no contiguous subarrays. If k is equal to 1, there will be one the number of contiguous subarrays. I will see. It just depends on whether. Let me think. Okay, I'll just return whether. I mean, for this one, if k is 1, I mean the product is at least 1, so we will all return 0 in this case. And and then this one, once it's larger, k is larger than 1, it will stop when the current product becomes 1. At this time, the let's see, the answer shall be 0. We want to check at this time the right and left plus 1. So this should be, for example, here. This one will give 1, and then it stops. Left here is, okay, this is 1, 2, this. I think we can start tracing this one. I wanted to check after we got the valid bundle, what does right left means here. So if the right pointer is 0 and this is 2, and we obviously get the number of length of 3 element. So how are we going to get the number of contiguous subarrays when we got the longest one that ends with right pointer? So let me think how to do this. So we can go through the example in the problem to see whether there's a pattern in doing this. Let's get started. Okay, so when right is at 10, we simply get 10, and when right went to 5, we got 5 as well as 5, 10, as well as 10, 5. Okay. So let's say at this time the left and right are both, they're both at 0. So they're both at 0. So in this case we do got just a 1. We just got 1 subarray here. And then if the right pointer ends at 5, we can go 5 or 10, 5 as a subarray, as a subarray. So let me find if there's a pattern. So when it ends, we got left at 0, and right at 1. So we got 2. Okay, so let's see the next one. If it ends at 2, we got 2 itself. We got 2, 5. How about 2, 5, 10? No, this is not gonna work, as 2, 5, 10 is larger than is equal to 100. And at this time, after we do this one, we definitely have shrinked the value already. So the left right now is 1, and the left here is 1, and the right here is 2, and 2 minus 1 plus 1 is 2. And then we end at 6. At this time, the left pointer has already been moved to 5 already, so we got 5 to 6, 6 to 6, and this would be left pointer equal to 1 and right pointer equal to 3. 3 plus 1 plus 1, 3 minus 2 plus 1 equals 2 plus 1 equals 3. So every time we update it from here, we wanted to update our result, and the result updated is this. So that's what I get, and after all this, I return the result. Okay, let's see. Okay, this is called answer, sorry.